Hello dear students, I am Vinayak Koppad. In this video I am going to explain you the pentagonal pyramid problem with the help of solid edge ST7 software. First we shall see the problem here. A pentagonal pyramid, 25 mm sides of base, 60 mm axis length, rests on HP on one of its edges of the base. Draw the projection of the pyramid and the axis is inclined to HP at 45 and to VP at 30 degree. So here axis is inclined to both the planes, means we have to solve this problem by locus method. So let's start the solution. So open the ST7 software and after writing the x and y VP HP, so go to the polygon by center. So here select the number of sides as 5 and again by vertex method. So draw the pentagon in such a way that the edge should be towards right of you, because in the solids we are taking the given condition in the right of us. So that's why it is 25. So drag it to the convenient position, and here we need to find out the midpoint. So by selecting a corner and opposite line midpoint, we have to join it. After drawing from all the corners opposite lines, so we have to delete it. Again this corner means again this, and we have left with one more here. So just connect from here to here, because in the pyramid we have to show the lines with the darker line, because they are all visible lines. So after this, go for the annotations and write down the annotations, and here it is O, and within the bracket it is O1. O1 is a midpoint of a bottom face of the pyramid. So now go for the line command and draw the vertical projection. Now the axis will be here and given length is 60 mm. Axis length will be 60 mm. Now take a line command from all the corners join to the apex of the pyramid. Now again connect the bottom lines. Now these are all the construction lines, projection lines. Make it thin. Now go for the smart dimension, show the axis length, and this will be change the axis line type. Now go for the annotation. So this is O dash. Now again this is A dash. Now this point is B dash, and within the bracket it is E dash, and this is within the bracket O1 dash, and finally so this will be C dash, within the bracket it is B dash. So this is the first position of the problem. In the second position, so it is inclined at 45 degree to the HP. So again leave a convenient space, draw a line at an angle of 45. Now again select all the lines and these lines we have to block it. Go for the move command and take a one copy of this. Now collinear this axis with this line and connect this end point to the XY line. Now you can delete this one and you can unblock. Go for the extend to next, extend the axis. Now show the angle here. Now again we need to write down the annotations. Just make use of a move command and write down all the annotations here. So O dash, and this is A dash, B dash, E dash, then this will be O1 dash, and again this is C dash and D dash. Now after this, draw the vertical projections. So from midpoint I will switch off. Again draw the horizontal projections. And remove first all the unwanted lines. So select the projection line, all the projection lines at a time, change the thickness to 0.05. Now so connect the corresponding points here. Now take a line command. Let's start from A. So the vertical B is here, B. Now so we have to look at for a C here. Now this is D. Now again E. Again E to A. Now all these actually will going to connect with the apex here. So first we shall connect to the apex, then we shall look at for the hidden edges. Zoom the area here. Yes, now we have connected from all the corners. So here the edge CD is not visible when you are looking from the top direction. That's why, so the CD we have to make it as a hidden edge. Also the edges which are connecting to these C and D corner, so all those lines we have to make it as a hidden here. So this is actually the CD edge, and here D is connecting with E, so as well as the vertical line. And similarly, so the C is connecting with D, it is connecting with B as well as the vertical line. So all these lines we have to make it as a hidden lines. Now so we have to draw the axis here, and before that first we shall write down the annotations. So this is A, B, and now again as I told you, C is not visible, write it within the bracket, and again D is also not visible, write it within the bracket, and finally this is E and this is O. So now again only thing we have left with the O1 here, so O1, so the O to O1 will be here, go for a split. So I want O to O1 line, and again so actually we have to show the O to O1 as an axis line type, but that is again going to cover by the O to A edge. That's why simply here we need to show only the annotations here, and again it is not visible, so write it within the bracket. Now this is the second position of the problem. So the third position, so in the third position, so it is inclined 30 degree to VP. So first draw a line at an angle of 30 degree. So if it is going beyond the sheet, so better you draw one horizontal line, and from that so you show the angle. Now again, so these are all construction lines, 0.05, go for the point, mark on reference point because this is a locus method problem. Again first we need to measure the first axis length, which is given in the problem as a 60, and after this we need the distance from O to O1, so which is coming out as a 42.426. So have to make sure that it is O to O1. Okay, now go for the arc by center point. So this will be the center. First radius will be 60. Cut this line, again draw the horizontal line, again go for the same command with the same center with the radius 42.43. so we need to cut this locus line. Now so first we'll connect here and select all the construction lines at a time. So we'll change it to 0.05 fit. Now our O1 should be collinear with this line. So again for that, select all the edges, zoom the area because some lines are very close to each other. Okay, these are the lines which are necessary, so that we have to block it. Go for the move command, so take a one copy of that. So approximately first we'll rotate this one. Now we'll use a collinear. Now go for the connect. This should connect with this one. Now we can unblock and take a annotations. All the annotations we need to write down again. So instead of writing, so as I told you, I will make use of a move command. Just go on placing at the respective positions. Change this to axis line time. So behind that there is one more line is there, that's why it is not visible properly. So we'll make this line as a axis. Yes, now it is visible clearly. So this is a locus method problem, that's why. So we need to measure the angle beta here, so which is coming out as a 45 here. Then go for line command. So draw the vertical lines from all the corners. The C corner is here, D, and finally E. Now O here. Now again from A, so you can extend up to this point. Similarly go here B, look at the B here, so it is, which is up to this point. Again C, so C is up to this point, and next D. So D vertical I have already drawn, so which is again coming on the same line, and finally E point, so E is also on the same line. Now so the O point, first we'll remove the extra lines. Otherwise we'll connect all the lines here. So first vertical A, this is A point. Now B, C will be this point, D will be this, and again E will be this point, and E to A. Now so now all corners again should meet or should connect to O point. First we'll connect it and then we'll look at for the hidden edges. Yes. So now when you're looking from the front direction, so the edge E and D, okay, so that means the edges O to D, sorry, it is not E and O to D, as well as so O to D as well as O to C is actually not visible when you are looking from the front direction. So that's why those two edges we have to make it as a hidden edges here. So select, first we'll write down the annotations. So this is A dash, now again this is B dash, C dash. Now D is not visible, so when you are looking from the front, so we have to write within the bracket, sorry, this not bracket, we have to write it, and finally E dash. Now look at carefully here, so the corners E and D, that means O to D and O to E is not visible when you are looking from the top direction. That's why, so we have to make that as a hidden edges. So O to D is this line, and again O to E is this line. Select those two lines, make it as a hidden edges. Now so we have to look for the axis line. So now take a line command, again O1 will be up to this point, so it is almost coinciding, so we have to make it zoom properly, otherwise it is difficult. It is at this point. Now select that line and draw the axis line tab. Yes, this is the complete solution, and here I have not made this as a thin lines, and also these lines we need to make it thinner. Yes, thank you. This is a complete solution. And again, so if you want to show it the beta angle, so as I have explained in my previous videos, so you have to go for the character map and write down the answer here itself, and select all this, copy, minimize it, place the cursor and press the control. So this is the complete solution. Thank you.